We're doing covalent bonding and drawing some Lewis structures. So here are our Lewis structures for the first elements. Everyone in the first row 1, second row 2, third row 3, fourth row 4, fifth row 5. Notice they're starting to pair. Sixth row 6, 2 pairs. Seventh row 3 pairs. And eighth row, noble gases are not interested in bonding. They have their full octet. So how do we draw Lewis dots? Well, we draw each of the elements and we combine them, boom, 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 to get the noble gas electron configuration of 8. So when we draw a Lewis structure, we use, instead of 2 dots in the middle, we use a line to show that there's a bond, that those are electrons being shared in between these 2 atoms. So you draw a line for a bond. So each bond shows or represents 2 electrons. Now, if we're using our little cards that we made, here's our hydrogen with 1 Lewis dot. I'll go back so you can see. So hydrogen and F. Hydrogen has 1 dot, F has 7, and a line. So when we put our cards together, we have H, and we connect the green line with that green line, those 2 free electrons, to make a bond. So that is the shared electrons that we draw a line. And then fluorine still has its 8 on its 6 on the outside, plus those 2, which makes 8. Okay, so we draw the same thing. So here we have our cards showing H has a bond with F, and then there's 3 pairs around the F. And when we draw the Lewis dot, there it is. Oop, moving stuff out of the way. We have H with a line showing that that's a bond, and then we have 3 pairs of these unshared pairs, which we'll talk about in a second. Okay, try to get me out of the way here. There we go. Okay, so once again, that line is a bonding pair of electrons. So there's 2, there's shared, so we can call them a shared pair, a bonding pair, a bonding domain. It's the same thing. It's 2 electrons being shared, okay, which is a little different than the, drum roll, the non-bonding electrons, which are these on the outside. They're not connected to anything. So we call those guys unshared pairs, or lone pairs, or non-bonding pairs. So these guys are still there. They are taking up space, which we'll learn later. So we have to pay attention to them, and it also helps us in the counting when we have 2, 4, 6, 8 electrons around the F. So by just looking at our Lewis dots, you should be able to, instead of having to write the cards, be able to tell this is going to make 1 bond. This is going to make 4 bonds. This one has a pair, so those aren't going to do anything, and 1, 2, 3 bonds. This one has 2 bonds. This one has 1 bond. And here's argon, noble gas. It has 8 electrons, which means it's not going to bond with anybody because it has its octet already. So back to our Lewis dots. Oh no, these guys are missing. Why are they missing? We're talking about covalent bonds here. So because they're covalent bonds, metals are not involved. That's ionic bonding, which comes later. So for now, they're gone. Oh no. So we're going to see carbon and silicon and nitrogen and phosphorus and oxygen and sulfur and fluorine and chlorine. We're not going to see noble gases. And we will see hydrogen, lots of hydrogen. And hydrogen likes to be, even though it's here over in the middle zone, due to its electronegativity, likes to fit right over here next to carbon and nitrogen when it comes to not being a metal with electronegativity. Okay, so now sometimes elements can form not just a single bond, they can form a double bond. So here's the oxygen, and if you remember the Lewis dots for oxygen, go back. 2 pairs, 2 lone electrons. So these 2 lone electrons can bond when there's another oxygen next to it, will bond with another oxygen in these 2 places at the same time, which makes, drum roll, a double bond. So we have 2, 4, 6, 8 electrons around this oxygen and 8 around this oxygen, and it forms a double bond to get the 8 electrons. Nitrogen has a pair and 3 electrons, and those 3 electrons come together to form 3 bonds. So that is a triple bond between the nitrogens. And if you counted the electrons, 2, 4, 6, 8, they each have 8 electrons. And I will show you the other method of doing Lewis structures rather than using the cards, which is so much easier, but not the official way of doing it. I will teach you the official way, which is the counting method.